All right, we're going to start our probability part of chapter 12. So 12.6. This is probability, slightly different than what you're used to. We're going to start off pretty easy with 12.6, and then it'll get kind of changing slightly. So hopefully the video helps you out with it. First of all, we're going to talk about the fundamental counting principle. I'm going to show you what a tree diagram looks like, but I'm not going to require you to do a tree diagram. It's just something that helps you understand what I'm saying, and then I'll get you to an easier spot with it. So here we go. So a greeting card maker offers 4 birthday greetings in 5 possible colors, as shown in the table below. How many different? Okay, so what I'm really going to focus in on is what the question is asking, because what you find with the probability is that you have to pay attention to the question to know how to do it. So you got to find keywords in it. This says how many different cards can be made from 4 greeting choices and 5 color choices. So I'm going to show you the long way, and then I'm going to show you the quick and easy way. So one way to do it is with a tree diagram. What? Not something that I want to do. But this is just showing you that you can make a humorous blue, a humorous green, a humorous orange, a humorous purple, and a humorous red. You can also make a traditional blue, traditional green, traditional orange, so far romantic, and from the group. So this is how I want you to do it. I want you to ask yourself remember this key question, how many things do you get to do? You get to do 2 things, and it's always multiplication, okay? Always multiplication. I get to do 2 things. I get to pick the genre of the card, and I get to pick the color of the card. There are 4 different genre choices: humorous, traditional, romantic, and from the group. And there are 5 different colors. So how many different outcomes are there? 20. Now listen to the words I said. How many different outcomes? How many different choices? These are called outcomes, okay? That's the fundamental counting principle. How many things do you get to do? Then you put what they are. What do you get to do? And that's what I'll keep saying to you. Then you just multiply the numbers. So you have 20 different outcomes. So the next question. An ice cream parlor offers a special on 1 scoop sundaes with 1 topping. The ice cream parlor has 5 different flavors of ice cream and 3 different choices of toppings. How many different keywords, how many different sundaes can you make? You're asking, how many can I make? So I get to do 2 things. I get to pick the flavor, and I get to pick the topping. There are 5 flavors, 3 toppings. There are 15 different outcomes, 15 different possible outcomes. Key words. How many different sundaes can be made? 15. Next one. A cell phone company offers 3 payment plans, 4 styles of phone, and 6 decorative phone wraps. I don't know what a phone wrap is. How many phone options, again, how many options are available? How many things do you get to do? You get to pick a payment plan, you get to pick a decorative phone, and you get to pick a style. So you got the payment plan, you have the style of phone, and you have the decorative phone wrap. There are 3 payment plans, 4 styles of phones, and 6 decorative phone wraps. So how many different outcomes do I have? Right. 72 possible outcomes. So there's 72 different ways to pick from those 3 choices. It's pretty easy. Now, let me tell you something else. outcomes, this 72, will always be your denominator in probability. Okay? So remember that. When I get to what is the probability of, the outcomes is what will be in the denominator, because in probability, it's total outcomes on the bottom. It's favorable on the top, what you want, over total outcomes. So keep that in mind when we get into the question of probability. Sandwich Shop offers 4 choices for bread, 5 choices of meat, and 3 choices of cheese. If a customer can make 1 choice from each category, here it is. How many different sandwiches? Well, how many things do you get to do? I get to pick bread. I get to pick meat. I get to pick cheese. That's all I get to pick. So I have 4 breads, 5 meats, and 3 cheeses. So multiply that out. What are you going to get for your final answer? Yeah, you have 60 different outcomes, 60 different ways for you to choose your sandwich. Who'd have thought? You could be in there for a long time trying to order because you can't figure out how you want to make your sandwich out of those choices. Henry rolls a number cube and tosses a coin. Okay, a couple of things we've talked about before with probability. In this book, they call it cube, not dice. Always assume that a cube is 1 through 6. It's fair, unless they say it's an 8-sided cube. Tosses a coin, always assume the coin has 2 sides, it has a head, and it has a tail. Okay, always assume it's fair. This question is different. It's what is the probability that he'll roll a 3 and, just so you know, and means multiplication, toss a head. Okay, so let's think about it. I have 2 things I have to do, right? I get to roll a cube. How many outcomes are there on a cube? 6, right? Remember I told you outcomes are the denominator of probability. How many outcomes are there on a coin? 2. And it says, what is the probability that he gets a 3? How many 3s are there? 1. And tosses a head. How many heads are there on a coin? 1. So what's the probability? 1/12. And you're done. Okay, they're going to go through the tree diagram with you, just so you know where that 12's coming from. Those are all the different combinations that you can do. This is the formula, favorable outcomes over total outcomes, which is what we did. Okay, this is how they like to write it. Probability of what you get to do. I like to write it as the probability of a 3 and a heads. And then I would say the probability of the 3 is 1 out of 6. The probability of the head is 1 out of 2. To me, that's the best way to write it. I'm not going to ask you to give me the combinations. What is the probability? So again, when it's probability, it's a fraction. You got to remember that, because once all this probability goes together, you have to keep track of when is it a fraction and when am I just looking for a number. Of winning a multi-state lottery game where the winning number is made up of 6 numbers from 1 to 50 chosen at random. Assume all numbers are eligible each drawing. Okay, so I'm going to ask you, how many things do you get to do? You get to do 6 things. 1, 2, 3, 4, 5, 6. Each thing has a total outcome of 50. Do you agree? Because there's 50 numbers you get to choose. And you get to choose them all at random. And remember, it's always multiplication. Multiplication, 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 multiplication. What's the probability that they chose your first number? What's the probability of the second, third, fourth, fifth, and sixth? So it's really just 1 over 50 to the 6th power. There it is. So you can be playing the lottery anytime soon. Or do you think maybe you might not play the lottery because you have 1 in 5,625,000,000 chance that it's your number they picked? You might want to rethink it. However, if you don't play, you got 0 chance of winning. So at least this is closer than 0. So do you want to look at that one again? Let's go back to this again. The probability of winning the lottery. You get to do 6 things, okay? You choose from the numbers 1 to 50. That gives you 50 numbers, 50 things you get to choose from. That's why 50 is in the denominator. The probability that it's your number is only going to be 1 out of 50, 6 times over. So that's where they came up with 1 over 15,625,000,000. Bob rolls a cube and tosses a coin. What is the probability fraction? So I know this is 6 and I know this is 2. That he rolls an odd number and tosses a tail. Well, we know we're only 1 tail. Odd number, I want you to think you got 1, 2, 3, 4, 5, and 6 on a number cube. So we have how many odd numbers? Yep. So multiply, you get 3/12 or 1/4. You should always simplify. What's the probability of winning a lottery where the winning number is made up of 5 numbers from 1 to 20? We'll try and do this one, so pause the tape, try to do it, and then turn it back on and make sure you did it right. You get to do 5 things from 1 to 20. That makes 20 numbers to choose from. The probability that they chose your first number is 1. Probability the second, third, fourth, fifth becomes 1 to the 20 to the 5th power, or 1 in 3,200,000 chances of you winning that lottery ticket. There you go. So that's the introduction to probability. So the 2 things we did there was the fundamental counting principle, where I said that you always say to yourself, how many things do I get to do? You get to draw that many lines, and you always, always multiply. Then probability rules off of that because you're still going to do the total number of outcomes in the denominator for probability, and then you ask yourself, you know, what is the favorable? That's what you want. That's your numerator. And then you multiply. Good luck.